everyone and welcome to this video. My name is Cliona, I'm a H1 chemistry student, and today I'm going to be taking you through the solution to question 6 from the 2020 higher level Leaving Cert Chemistry paper. And this question is based on fuels and thermochemistry, and it has a calculations question at the end. So let's get right into it. So at the start, we're given a short paragraph just telling us about petrol, how it's a mixture of hydrocarbons, okay? And you can see that there's 2 underlined terms. And then in question A, which is worth 8 marks, we are asked to explain the underlined terms. Okay, so the first underlined term was knocking. Okay, and to be honest with these two definitions, these are 2 of the definitions in fuels and thermochemistry because there are a few that you will really just have to learn off. Okay, so knocking is a result of petrol auto-igniting. Okay, and auto-igniting basically means igniting before the spark is produced. And the way I used to remember this from my Leaving Cert is if you have a gas cooker at home, or if you know someone who has a gas cooker and you have to produce a spark by usually pressing in a button before the fire can ignite, okay? So this is worth 4 marks for saying that it is a result of auto-igniting, and you can also say igniting before the spark is produced. The second definition is the octane number, right? So the octane number is the measure of tendency of a fuel to resist knocking. So it's basically a measure of how good a fuel is at resisting knocking. And again, this is 4 marks. You could also get your 4 marks here by saying that it's a fuel performance rating based on its equivalence to a certain mixture of heptane and 2,2,4-trimethyl pentane, okay? This is another definition of the octane number that'll get you your 4 marks for this question. Okay, so now we have question A done. We're going to move on to question B, which has 3 parts. So the first part asks us to name the type of oil refining reaction in each of the 3 equations above, right? Okay, so these are 3 equations, and we're going to find out what type of oil refining process are in each. So the first one we can see must be catalytic cracking, right? Because it's broken down into shorter chained molecules. So the reactant C14H30 here is broken down into 3 smaller chained molecules. Now we don't know what 2X is, right? But we can see that C2H4 and C6H14, right? So X must be C something, H something, because they're the only 2 atoms, C and H, in the reactant side of the equation, okay? So that is catalytic cracking. Now the second one, okay, and when I see a H2 in the product, okay, in an oil refining process, I know straight away it's dehydrocyclization because hydrogen is produced, okay? And it's in the word, dehydrocyclization, okay? So hydrogen is coming out, okay? Okay, and the last one here we can see is isomerization, right? Because the product is an isomer of the reactant, okay? And we can see even by just looking at the formula that the product has much more branches than the reactant, right? So it's going to be basically a better fuel because it's more branched, okay? It's going to have a higher octane number. Okay, so these are the 3 answers to B part 1. So the 3 types of oil refining reactions, so they're 3 marks each for catalytic cracking, dehydrocyclization, and isomerization. Okay, and you could also say reforming for dehydrocyclization and isomerization. Okay, you could replace them by reforming, and you will still get your 6 marks only if you write reforming twice. Okay, so now let's go back to the question. So we have B part 1 done. Now B part 2 asks us to deduce the formula of hydrocarbon X. Okay, so let's do that. Okay, so the formula where X is present is the following. So we know that X must be C something, H something. Okay, but we need to bear in mind that there's 2 of X, so we'll bear that in mind further on here, right? Okay, so how many C's are already used up? So there must be 14 in total on the product side. So 14 minus 2 here, minus 6, okay? So 14 minus 2 is 12, minus 6 is 6. There's going to be 6 C's left for this middle product, okay? So let's just write in 6. And how many H's are left? So there was, we're going to use purple for this, there was 30. So 30 minus 4, okay, minus 14, which is here. So 30 minus 4 is 26, minus 14 is 12. Okay, so this H is going to be 12. Okay, so that is 2x, my apologies, right? So x must be C3H6, okay? Because we're going to divide both numbers by 2, right? So I'm just going to write that a bit more neat here. So x is equal to C3H6. I'm going to draw a box around it. Okay, and for this, you are going to get 3 marks. Okay, so now we've done B part 2. Let's move on to B part 3, which asks us to give the systematic IUPAC name for the product in the third equation. So this is what we're looking for. So whenever I'm asked to give the systematic IUPAC name, right, and we have the formula, the first thing I do is I draw the formula, I draw the molecule, and then see if I can deduce the name. Okay, so the name of the product is CH3, CH, CH3, CH2, C, CH3, CH3, CH3 is at the end there. Okay, so now let's draw this. So we have C with 3 H's, and then we have C with 1 H, and 1 CH3, and then we have C with 2 H's, and then we have C with 2 CH3s, and then we have another C with 3 H's. Okay, so the first thing I do is I count my carbon atoms, and here we have 5 carbon atoms, so it's going to end in pentane. So I'm just going to write that in straight away. Okay, now it would just be pentane if all of these CH3 molecules here were just H's, okay? But they are methyl molecules, right? And there's 3 of them. And where are they located? Okay, so this is going to be carbon 1, this is going to be carbon 2, carbon 3, carbon 4, and carbon 5. Now, why are we labeling them backwards? Okay, it's because we can see that there's two methyl molecules on this end, okay, this end here of the chain. So we want that to be carbon 2, so it's a lower number, right? Because there's only 1 then on carbon 4, right? So there's 2 on carbon 2, so it's going to be 2, 2, and there's 1 on 4, okay, 4, right? Trimethyl, because there's 3 methyl molecules, trimethyl pentane, okay? So 2, 2, 4, trimethyl pentane. Okay, and that just should be all one word. And for getting the name of this, okay, you are going to get yourself 3 marks. Right, so that's question B done completely. Now let's move on to question C. So in question C, we're told that petrol may contain oxygenates, right? And C part 1 asks us to give an example of an oxygenate used in petrol. And question C part 2 asks us, why are oxygenates added to petrol? Okay, so for C question 1, we're asked to give an example of an oxygenate used in petrol. Now, there's a good few you could choose. The one I always remember is propanol, because it's an oxygen used in petrol, which begins with P, and propanol begins with P. So you'll get 3 marks for that. You'll also get 3 marks if you say methanol, ethanol, butanol, or MTBE. Okay, so the second part to question C asks us, why are oxygenates added to petrol? And oxygenates are added to petrol, okay, to increase the octane number of a fuel. Okay, and for getting this, you're going to get 3 marks. Okay, you can also say that oxygenates are added to petrol to reduce pollution, which will also get you 3 marks, or else to reduce knocking in the engine. And again, that's 3 marks. Okay, so that's question C, part 1 and 2 done. So now we're going to move on to question D. And question D has 2 parts. The first part is a definition question where it just asks us to define heat of formation. And then the second part is a calculation question, which we'll go through. Okay, so we're asked to define the heat of formation. Again, this is just one of these definitions in the heat of formations and thermochemistry chapter that you really should just learn off. If you can, it's easy marks if you have it off by heart, okay? So the heat of formation is the energy released, okay, when 1 mole of a substance is formed from its elements in their standard or ground states, okay? So you're going to get 3 marks for the first 3 lines that I've underlined, okay? So energy, 1 mole formed, 3 marks for those, and then you're going to get another 3 marks for saying from its elements in their standard or ground states, okay? So that is 6 marks altogether, and 6 marks is a high number of marks for a definition, okay? So this is just why I would encourage you to learn these definitions. Okay, so now this is the final question, right? And just to clear up here, it says 21 marks, but that's actually for part 1 and part 2. So you've already gotten 6 marks for part 1, so this is actually worth 15 marks, right? So we are told that the heats of formation of propane, carbon dioxide, and water are minus 104.7, minus 393.5, and minus 285.8 kilojoules per mole, respectively. And we're asked to write a balanced equation for the combustion of propane in a plentiful oxygen supply and use the data provided to calculate the heat of combustion of propane. Okay, so let's do what we're asked first, okay, which is to write a balanced equation for the combustion of propane in a plentiful oxygen supply. Right, so propane is C3H8, right? So, and then it's combusted in oxygen, right? So O2, and it is going to produce carbon dioxide and water, okay? When something is combusted, it does produce carbon dioxide and water, okay? I'm just going to draw that O a bit bigger. So now let's balance it. So what do we have on either side? We have C, carbon, we have hydrogen, and we have oxygen. So they just stand for left-hand side and right-hand side there. So on the left-hand side, we have 3 carbon atoms. On the right-hand side, we have 1. On the left-hand side, we have 8 hydrogen atoms. On the right-hand side, we have 2. On the left-hand side, we have 2 oxygen atoms. And on the right-hand side, we have 3. Okay, so first things first, we're going to get 3 carbon atoms on the right-hand side. So I'm just going to write in 3. So then this becomes 3, but also oxygen becomes, so there's 6 oxygen atoms here, and there's 1 more, so there's 7 oxygen atoms. Okay, now, next thing, we're going to make this 8. So we want 8 hydrogen atoms on the right-hand side. So if we put a 4 here in front, right, then we have 8 hydrogen atoms, and we have 4 oxygen atoms here, and we have 6 here. 4 and 6 is 10 oxygen atoms on the right hand side. Okay, so now the carbons are balanced on both sides, the hydrogens are balanced on both sides, okay, but now we need to balance the oxygens. So we need 10 oxygen atoms on the left hand side. So how are we going to do that? We're just going to put a 5 here, right, and that becomes 10, and now they're all balanced. Okay, so the equation, the balanced equation is C3H8 plus 5O2 will give us 3 carbon dioxide plus 4 H2O. Okay, so that's the balanced equation, and we'll need to use this, okay, as we keep going through the question. But for getting this, you're going to get 3 marks. Right, so we want to find the heat of combustion of propane. So we want to find the heat of combustion of this equation, right? And we're going to find this by using the heats of formation of propane, carbon dioxide, and water. So I'm going to write we have, and this is just what we're given. So the heats of formation of propane. So we know propane is C3H8. So to get propane, we need 3 carbons plus 4 H2, right? And the heat of formation of that is minus 104.7, and that's kilojoules per mole, right? Now, the heat of formation of carbon dioxide. So we're going to get CO2. It's going to be C plus O2, right? And the heat of formation is minus 393.5 kilojoules per mole. And the heat of formation of water, so we're looking for H2O, so 1H2 plus half an oxygen molecule because oxygen exists in O2. Okay, the heat of formation is minus 285.8 kilojoules per mole. Okay, so what we want to do is we want to find this equation, right, within these three equations. So we're going to have to swap and multiply and cancel until we get the top equation, right? So let's see how we do this. Okay, so in the first equation, we want to swap it. Why do we want to do that? Because we want propane to be on the left-hand side, and at the moment, it's on the right-hand side, okay? What do we want to do with the second equation? The second equation, we want to multiply it by 3. Why do we want to do that? Because we have carbon dioxide, it's on the right-hand side, okay? But if there's only one of it, we need 3 of it, okay? The third equation, what do we want to do? Let's have a look. We need to multiply it by 4, okay? Because we can see that H2O is here, it's on the right-hand side, but we need 4 times what's here, okay? So let's swap them and multiply them and see what we get. So the first equation is just going to be, oh my apologies, I'll use my blue pen again. C3H8 will give us 3C plus 4H2, okay? And the heat of formation of that is just going to be, change the sign, so 104.7 kilojoules per mole, right? The next one we're going to multiply by 3. So we're going to have 3C plus 3O2 will give us 3CO2. We're going to multiply the heat of formation by 3. So our new heat of formation is minus 1180.5. We're also going to multiply the final equation. So we're going to have 4H2 plus 2O2 gives us 4H2O. And the heat of formation is going to be minus 285.8 multiplied by 4. And that's minus 1143.2. Okay, so I'm just going to bring down the equation that we need down closer here. Okay, this is the equation that we're looking for. So what can we cancel on both sides here? So there is 3 carbons on this side here and on this side here. So we can cancel them. There's 4 hydrogens here and here on the left hand side and the right hand side. So we can cancel them. Okay, so what are we left with? We're left with C3H8 plus 5O2 will give us 3CO2 plus 4H2O, okay? And that is exactly what we're looking for up here, okay? So to find the heat of combustion of this here, what we're going to do is add these 3 together, okay? So let's just get our calculators and do that. So we have 104.7 minus 1180.5 minus 1143.2. So the heat of combustion is minus 2219 kilojoules per mole. Okay guys, so you're going to get 9 marks for your final answer here, okay, which is the heat of combustion. You can also get 3 marks for these 3 here, so 3 marks for this, 3 marks for this, 3 marks for this, okay? But you can only get a maximum, obviously, of 15 marks for the whole question. So if you say don't get the final answer, but you get all these correct, okay, you're still going to get 12 marks because you're going to get your 3 here and you're also going to get your 3 for working out this balanced equation here. Okay guys, so that is question D part 1 and 2 done, completing the question. I hope that you found this solution video helpful and that it might have cleared up any queries that you may have had in relation to the question. And I hope to see you all in the next video.